Hello everyone. Today we're going to be doing a tutorial on Cryptic cycle. The module looks like this. It has a green background with glyphs on it and two arrows that can change between keyboards. Now the only edge we need is the number of ports on the bomb, which in this case is 0, so you can just write down 0 ports. And as a diffuser, we will now want to tell the expert how many rotations from north the dial is rotated. So if the dial is pointing up, it would be 0, right would be 1, down would be 2, and left would be 3. So let's get those right now. We have 0, 2, 0, 1, 1, 2, 3, 1. Next, what we want to do is add the number of ports to this, which would be 0, so we don't need to do anything. And if this number is odd, the first bit of the dial is 1. So each dial has 2 bits. When put through, these logical operators will return truth values, which can be used in here for a logic cipher. So we will check the parity of these numbers, and if it's even, then it would be a 0, and if not, it is a 1. So that becomes 0, 0, 0, 1, 1, 0, 1, 1. And that is now our first bit of the dial. Next, what we need to do is we want to get the number of letters from the dials. As you can see, they're all in glyphs. So what we need to do is go to this table, and the diffuser will have to describe to the expert what glyph it is. So for example, this one right here is A, and the expert will also need to note down which set, 1, 2, or 3 it is in, as this will be needed later. And then the diffuser will also need to identify a part of the glyph and describe what orientation it is pointing. So for this glyph A, we could describe that the large middle part is pointing upwards. Then, as the expert, you need to figure out how many rotations that is from north. So for this glyph right here to have the middle part facing up, it would have to be rotated 3 times clockwise. So we want to write that down. It would be rotated 3 times clockwise. Then we repeat this for every other glyph. So this glyph right here, well, that is a V in set 3, and then the diffuser might describe the glyph as the fish head points southeast, and so we can tell as the expert that sorry, that's U set 3, that it has been rotated twice. And then we will repeat this for every other glyph. So this one is G in set 2 and has been rotated 0 times. This one is B in set 1. It has been rotated 0 times as well. This one right here, well, that's D in set 1, and it has been rotated 3 times. This one here, well, that one is V in set 1, and it has been rotated once. This one right here, well, that is that would be this one right here. That's Y set 2, and it has been rotated twice. And then this one right here, that would be D set 2, and that is rotated 3 times. Next, what we're going to do is, if the parities of the number of dial rotations and the number of label rotations from north is the same, then the bit is a 0, but if not, it is a 1. So in this case, we have an odd number and an even number, so therefore the bit is 1. Here we have 2 and 2, which are the same parity, so that would be a 0. 0 and 0 have the same parity, they're both even. 1 and 0 have not the same parity, so it's a 1. 1 and 3 do have the same parity, as they're both odd, so that's a 1. 2 and 1 have different parity. 1 and 3 don't have the same parity, so it's a 0. 2 and 1 have different parities, so that's a 1. 3 and 2 have different parities, so that's a 1. And 1 and 3 don't have different parities, so that is a 0. And this is now our second bit. We'll now move our decrypted letters down a bit, as we won't need them for a while. Next, what we need to do is find our logic operators, and to do this we will have to separate our 8 dials into 2 groups of 4, and they will be the top 4 dials and the lower 4 dials. However, when reading the word, you should go left to right, going in a zigzag form. So we will now divide the dials and note their directions. So the first one would be up, up, right, left, and the second one is down, right, down, right. Next, what we want to do is, starting from the center at OR, we want to move in the direction shown by these dials. So up, up, right, left, and that gives us this operator. And then we want to do the same for the second set, so starting from OR, down, right, so we have the NOR operator. Then what we need to do is we need to put these pairs of bits through the operators and get their true-false results. So for this one right here, everything except 1, 0 returns true. So it'd be true, 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 false, true, true, false. And then this one, NOR right here, well, it's everything is false except 0, 0. So it'd be false, true, true, false, 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 false. Right, now what we want to do is we want to go to this table here with all the letters and the truth values. And what we want to do here is we need to find the column that has the 2 truth values in it. So in this case, we're starting at the top. First truth value is true, and second truth value is false. And then we want to go down until we find the first letter of our encrypted word. So we want to go down until we find the letter A here, and here it is. And then we want to go across left to the letter in the large column that it is, and that means since it's row S, our first letter of our decrypted word is S. We want to do this again for the second letter, so true, true. So we go down the true and the true column, and then we go until we find U, and we go down until we get U, which is a T, which is in this row. We go across left until we get the big letter, which is T. And then we do this again, true, true, we're looking for G, here it is, and it goes across to the A row, and then true, false, we find B, which is here, and we go across to letter N, false, false, we're looking at D, we go across here, false, false, and we look at D, and it goes across to D. True, false, we're looking for V, and here it is, V, and it goes across the letter A. True, false, we're looking for Y, that's here, and then we go across left to the letter R, and then false, false, and we're looking for D, here it is, and we go across the letter D. So that means our decrypted word is standard. But we're not done yet, because now we have to submit a response word. To find your response word, we have to go to this table down here with all the words in it, and we have to find the word in bold that is our word. So our decrypted word is standard, which is here, and now our response word should be below that, which in this case is wingding. Next, what we have to do is encrypt this word using the truth values we have. So from up here we have the truth values, and now we want to encrypt the word wingding using these truth values. To do that, we want to start by taking the first letter of our response word, going down the left large column until you find it. Here it is, it's in the W. And then we want to go across until we reach the column that has our truth values in it. So we want to go across the column that has true false in it. So that is the second column, and that means our first letter of our encrypted response word is Z. Next, we want to find the second letter, which is I, and then go across the column that has true on it, and that leaves us with B. And then we repeat this for every next letter, so N in true becomes A, G true false, that becomes H, D false, that becomes D, I true false, that becomes S, N true false, that becomes B, and then G false, that's an R. So now what we want to do is we have our encrypted response word, but then you may notice that we only have glyphs. So how do we input the response word? Well, to do this we need to take the sets that we found before, and we need to encrypt the response word using the glyphs we have in the sets of these dials. So because this is a set 3 glyph, we have to encrypt the first letter using a set 3 glyph. So to do this, we go to the table and we take our first letter and as the row and the set as a column, and then we see this glyph right here. So we describe the glyph to the diffuser, and this one is the one we want. Then we repeat for every other glyph, which should be this one here, and then we need to change our keyboard because each set has its own keyboard. So if you can tell the diffuser which set is on, then this often speeds things up a bit. And then once you have put in all of the letters, after it inputs, it will automatically submit your word. So if you make a mistake, you will need to, for example, I made a mistake here, so I can just press this button right here. So you want D in the set 1, well, that should be this one right here. S set 1, that should be that one right there. B and R in set 2, that's that one right there. And then finally we need R in set 2, and that's that one right there. And then once you do that, the module will be solved, and it will have a cool glitchy effect, and that is how to do Cryptic Cycle. So I hope you found this tutorial useful, and yeah, bye.